So today we will focus in a very simplified way. We'll try to understand Gen AI from the leadership perspective. Then we'll try to understand some key fundamentals, especially if we have to make a decision, lead an organization, or even if you're trying to build an application, knowing some fundamentals is helpful. And then we'll look around what does this means for the leadership model and how to make those decisions, and then best practices in industry. And I'm going to show you the applications which we have built and use cases around that and the platforms we are putting together. So as I said, this is designed for all three persona. If you are a business side person who is a super user, operations head, and you want to reinvent your organization in multiple ways, that you will get those concepts. For entrepreneurs who are building some new application or modifying and trying to use Gen AI for their own needs, and expert level, even if you are a data scientist and an AI professional from past, or a CTO, CIO, or CEO who's leading an organization, how you pivot knowing this technology. So it's designed for all three. So let's start with Gen AI. What is Gen AI? Gen AI is a subset of deep learning, and it is from the discipline of artificial intelligence. So artificial intelligence is broken down mostly into machine learning, which got very popular. Then we have deep learning, and then now generative AI. So how this is different, let's look at it. In deep learning, the comparison I'm going to do is deep learning versus generative AI, and I will show you a little bit of ML side too. So in deep learning, we had a discriminative technology which we have built, where we are able to basically say, is it a cat or a dog? Those kind of classifiers we are building. Till the generative AI came. In generative AI, we are able to train the models on unstructured data and is able to generate some new content. So let's look at this. Machine learning output, you have a labeled output and you get a labeled prediction. In generative AI, you have a pattern of unstructured content and your output is another content. Like for example, in ChatGPT, you prompt text content, it understands it and it gives you a text output. You have a lot of GAN models which does cross things to text to image. We'll talk more detail, but this is at the basic level. That's what Gen AI is doing. This is a landscape of generative AI. So it does various kinds of things with different GAN models behind it. So text, code, image, speech, video, 3D, and other stuff. Now, the next topic I'm going to talk is large language models. So what are these and why they're important and how they are built and what we should understand from the management, leadership, or entrepreneur point of view. So this is a landscape up till 2023, and this is growing exponential, not multiplier. So every company, including Apple, announced that they are now working on their own large language model. So it started in 2019, where even I got involved around that with OpenAI. They used to call GIMSM or GIM model. From there, 2024, we have 2023 ChatGPT-4. So you can see how they are growing. T5, GPT-3, I'm not going to read all of them, but this is the landscape of large language models. So what does these large language models? They are pre-trained machine AI models, which are pre-trained. And what you do is you tap into these models to get in a prompting way or other ways to, you can tap into these large language models, fine-tune for your own application building. So what affects and what makes the large language model? What affects the large language model? Their efficiency or the value is considered based on the number of features it has been trained on. So feature engineering is something very fundamental to machine learning or AI, which helps us to do the right prediction and right configuration for the AI prediction part. So let's look at what does this parameter increase means. So if you have a 350 million parameter to 750 to 20 billion. You can see how this image is been processed and how beautiful and better it gets as number of parameters we use for training these models. So now let's look at how large language models and how many features they have been using parameters to train. It has gone to now from billions to trillions now by 2024. So GPT-2 was 1.5 billion, GPT-2 was 1.5 billion, GPT-1 was 20 billion. To GPT-4 is undisclosed, so that's surprising. There is some of them are 20 billion. So now you understand the power of the large language models are based on the parameters involved in the training phase. So one of the things you want to, when you make a decision, how powerful is the model? So basic things to look at is this way, plus you will test and program, obviously. These are some popular ones: OpenAI, Google Palm, DeepMind. Whatever your customer, your needs are, based on that you can drive this. We took very extensive interest in building medical bots. So these are some medical popular large language models. MedPalm recently was released. This is trained on T5, which was a language translator model. So now they took this Google took this medical terms and retrained T5 to call MedPalm, and look at the improvement from December of 2022, PubMed, which was 50.3% to 86.5%. It's able to qualify a lot of medical exams and possibly beat a lot of theories around medical. So that's what it is. Now, the next topic we are going to talk is GPT. So what is GPT? There's a confusion between ChatGPT and LLMs, so that's why it need to be clarified. They are generative pre-trained transformers. What does GPT stand for? So what does it mean? You are seeing ChatGPT as one of the very pioneer, which we all are using. They are pre-trained transformers, which you'll see it more, has more. So let's look at between GPT and ChatGPT. So GPT is a large language model, and ChatGPT is an application sitting on top of large language model. That's what I wanted to little bit clarify here for someone who is a super user. And it has a large neural network, GPT, with 100 billions of parameters. So we saw what are the parameters. Now, on the ChatGPT side, you have a dialogue way to prompt, which is prompting, has a content filter and gives you a response in terms of text. So it's an application on GPT. Now, this is where the magic starts, and this may be a little bit involved technically. So generative artificial intelligence, there are two kinds you can look: generative general purpose one, and the task specific generative intelligence. Task specific can be also taken as different kind of transformer, GAN models, which are generative adversary network, variational and autoencoder, diffusion models, and flow models. This is going a little bit deeper than normal I go to. But if you are looking to build up an application in GenAI, so these concepts will help you to think better as well as make right decisions. So let's understand the fundamental behind this technology. They are called GAN. So GAN are generative and discriminative neuron network which compete with each other. So the basic function of GAN is there is one neuron network which is a generator and one neuron network which is a discriminator. So generator consider random value as an input, and discriminator is trained along knowing that input is true or not. It is trained as a classifier to give you a binary output, yes or no. When it does give you an output, it also have a loss function which feeds back to generator, and generator will learn from it and move on to create new input for discriminator to be re-challenge the discriminator. So let's look at this concept. What is happening now? We have two neuron network. Generator is taking a fake image. For example, it wants to create a cat image. It assumes that a vector, which is a data input, that this is a cat. It gives to the discriminator. Discriminator is already pre-trained to know is cat or not cat. So it will say it's real or fake at highest level. This is how it works. But let's look at how they interact now. So the first attempt of generator is, okay, it got some kind of an input, imaginary cat data, which is a vectorized data, and said to the discriminator, this is a cat. Discriminator says, no, this is not a cat, but it gives a loss function back to the generator. So generator sketch it again, create some new data with his ability. And then discriminator says, no, it is not a cat, but it shows a loss function to generator. And finally, generator is able to make an imaginary cat, which is very close to discriminator, cannot say that this is not a cat, and it wins. So this is how the GAN works behind the scene. So you take an imaginary input, you put to the generate. For example, you want to generate a fake $100 bill. Generator will generate a fake $100 bill, but discriminator know that this is not a real bill, and it will give back the loss function, and generator will keep challenging it, and at the end, generator ends up winning or equal. So a new content is generated. So in probability theory, this is what PG is the generation, and PR is the distribution of the real image. So generator goal PG in probability theory wants this distribution to be very similar to the realistic image. So almost generator will be able to mimic what the discriminator probability is there. The goal is to approximate the PG to PR distribution. So now let's look at how to build application around this technology. There are various kind of GANs. I'm not going to go all through, but I'll show you some examples. This is called cycle GAN, where you are able to swap a zebra versus horse. And these are all scientific papers how to do it. There are text-to-image generators, which is BERT also. You put in text image, it will be able to make an image. You can generate create fake human beings. This is through generator and discriminator model. Pose, you can take an image, a picture, and try to create different poses rather than having a model to take various 3D object generation, which is becoming very popular. We recently got a request from a company in Latin America to do some work around here. That was very exciting. Application is game theory, music, art. You create tons of applications using GAN models. Stable diffusion. This is one of the things which I want to talk about. So you see here, these are all imaginary character and imaginary objects which are been created, and you can see a cat trying to eat a piece of chicken, and as well as dog trying to eat. But it's the same. It's a data manipulation more than creating the real image. We'll see more details. So I'll go a little bit more. This is the third box is called diffusion models. That's what you saw in the last slide. And so I'll explain it a little bit more. So these are the basic three models. GAN, which we talk about, discriminative and generative. Then there are VAE, encoder and decoder model. And then flow models, which can reverse your image, cycle GAN, and all those things. And diffusion models it can go forward, backward, change the background, make it small, big, fill the gaps, those kind of things. Diffusion model, one of the example is we create fake images, which we have built application. A real person does not exist, but with generator and discriminator in diffusion model competing, you can have a person which does not exist. So in this one, diffusion model trains human faces can generate a new face with unique features, the model transform simply distribute into complex through reversible operations. So this is diffusion models. Let's look at VAN. VAE, variant encoder decoder. Best way to explain is when you are at airport and you see you have put something which airport does not like this their system, and it detects that your bag need to be rechecked. This is anomaly detection using variant auto encoder models. It is also like it can anomaly detect, it can detect something which is out of the place. In this case, you see if the fish is going in one direction, but the red one is going in another direction, it goes an anomaly. Just to give you very high level understanding so that we can build our thinking better. Flow models. Now, flow models are semantic data generation, you can say. So the simplest way I explain semantic and synthetic is you have piano, you have a guitar, and you have a drum. All these three music can be mixed and new music can be created. So that is semantic data generation. So data piece, adding semantics, smoothing integration, and new data and content is generated out of it. Another concept which we need to know, which will be required for us to understand in terms of building application, synthetic data generation. So you have this has solved a lot of big problems in industry, especially for mid-sized and small companies like us. Data was one of the biggest challenge since doing this for a very long time. So now you have original data, you can take partial data and you can have a full data synthetically created. It is a combination of various rows and columns using some probability combination. I used to call computationally statistical data generation method. Now it's tagged as a synthetic data generation. So for example, you have a credit card fraud system and you have people approaching certain level of companies from, let's say, Asia. Can you take that data and replicate in US? Yes, you can. By doing some kind of semantic adjustment, you can take that experiment and run it here and test your models rather than going and asking new kind of data from anyone. The other big use case is in the medical. It's crazy. With HIPAA compliance and everything, we were not able to do a lot of good experiments because of we don't have enough data. Now you can do diffusion models, you can do semantic synthetic data generation, and take one MRI and produce it in 1,000 ways with different age group, different bone density, different kind of parameters been changed. So you can build models around that very quickly. And you can feed the real data and see how good it is. So these are the power of GAN and how it helps us to, help us to speed up our development process. Synthetic image generation, as I was saying, we have used it in our experiment too. So these people, human beings, they do not exist, but with using cycle GAN, we are able to create some mixed human beings. You can mix also two human beings and have a third face, or take an imagery data set and process it and create a human being out of it. Last concept is prompt engineering. This is also required in terms of understanding how large language models are built and how to process them throughout this either as a super user, as an entrepreneur, or someone who's building the application. I'll keep it very simple. There are three kinds of concepts here: prompt design, prompt engineering, and prompt template. Now, prompt design is you build a prompt to get into large language models. You can either physically submit it. Some applications allow you to submit the whole document and take the intelligence out of the document and keep working on it. Prompt engineering is where you are intelligently writing some sentences to the chat GPT. It takes, we call word to vector. So the first sentence will be converted to vector. And if you give sequence of sentences, it falls into word embedding. So it finds out sentence A, sentence B, sentence C correlationship and make a semantic understanding of what those correlationships are to go to the LLM and get a very intelligent response to it. There's no, for a very super user, there's no what you call, it's a probability theory which is working and predicting the next word rather than the way our neurons work in our brain. There's no cognitive, it's all mathematical responses. Prompt template. This is for the people who are building applications. So when you tap into large language model, you need to do some kind of a getting in and getting out process. So you'll define what your request will be sent and how it will be sent, in what tone, what language, how many parameters, and when it gets the response, what kind of response you want to bring back. So this is done when you build a large language model application. So for example, you want to limit some ethical consideration. You don't want bad words to be going or coming out of a large language model, or you don't want bad personality to be passed, bad content to be passed to your large language model. You can have the filter and the prompt template, and when it responds, you can say, this content is machine generated, it's not to be used for medical or any advice. Those kind of things you can control here and more. You can also set up an example which it can learn from and tap into the large language based on certain examples. So normal user may be prompting whatever it feels right. You can control a lot in the prompt template design. I get a lot of questions around how to do efficient prompting. I assembled something quickly a long time when I was giving a talk on prompting, but you have to assume it like a personal assistant and give a very detailed step-by-step instruction and follow up. Basically, change, summarizing. If you are a super user, there is a limit to the response and limit to the input taken. So you can find by asking those kind of questions. One other thing I discovered, sometimes ChatGPT will never give you a link, but you can ask the keywords to search that link in other platforms. So there are indirect ways to get a lot of information. Those are some best practices for the prompting side. So I see anomalous. I gave the background of TDM, and there was someone asking for the invitation. I think we already sent to you. Then another one was, does Gen AI means based on LLM model or other models too? Yes, there are a lot of other models which I explained. When GPT reached plateau, I don't understand the question. If you can give me more insight. Will uncanny valley will be taken into account for stable diffusion similar model? I have no clue what this question is. So please elaborate it, and I will open for live question as I keep going. If you can elaborate your questions, that would be lovely, so that I can make very intelligent. Let me allow you guys to talk so that I can, couple of people who are requesting, I can answer it intelligently.
Hi, can you hear me?
Yeah, I can hear you. Who is this?
Yeah, hi. This is Kieran, and I'm based out of San Jose. And the question I had was, we have this so-called agile Scrum meetings that happen every day, where a Scrum Master runs the meeting. Mm-hmm. And if you look at what happens in an agile Scrum meeting, it's just basically, there's participants or the developers who answer a few questions in a very structured and fixed format. And this guy, or the Scrum Master, also responses are also very structured. Now, can we automate the whole experience and make the Scrum Master an agile? Well, it's after all on Zoom calls. So can you make an imaginary person or user that can run the Scrum meeting? Now, if so, what kind of models that would fit this? Am I making sense?
Yeah. So you want you don't want a pre-trained response. You want a natural response. That's what you meant.
Yeah. Not only that, because the AI Scrum Master, if you design one, will be having all the information at the fingertip. In other words, if there are like 100 user stories to be completed,
Uh-huh.
and he or she, the AI Scrum Master will know at the fingertip all the things and whatever the stages they are, how many are pending, how many completed, who is delaying, and how much time that person or a developer is taking. It's so magical if you can automate this, right?
Yeah, yeah. That. Um, so you want AI to do that task assessment?
Correct. The question is, what
Yeah.
kind of a model we should go with instead of LLM models?
Yeah,
Is
that
there
can be.
any?
That's what I was going to say. This is not a large language model. This can be, again, simple AI, machine learning driven prediction and learning.
Prediction and learning. Okay,
Yeah,
it could
yeah.
be supervised learning, some kind of a
Yeah,
supervised
yeah.
learning.
Supervise or, yeah, it exactly falls there. Generative is content generation, fine tuning, and finding the answer based on the feed you give to it. And it can be combo model too, by the way. It can give you suggestions.
Gotcha.
It can give you predictions, reading predictions. It can tell you these are the 5 steps if you are delayed in the project to take those kind of things. You can do a good combined model out of it. But if you are trying
Gotcha.
to take a intelligent dashboard, which I'm thinking, and you want to make it more intelligent, that will be falling in the predictive modeling side. So
Yeah.
let's
Basically,
say
the words spoken by.
there's a resource which is always delaying his task and quality is drop, right? Based on
Correct.
task resource, you can literally predict the trend of this person working and then also tap into large language model with that persona, give him some feedback and recommendation how to correct.
Correct.
So I hope it was helpful.
That's correct.
This is our team, very diversified team. I'm very proud to bring almost possible every nationality and every race in the room. This is our office. We are based in 2400 Barranca Parkway in Irvine. So we are very local. If you are from Southern California or around here, you can always stop by at our office and meet us too in person. These are some credibility for TDM. TDM has been in business since 2015. We build a couple of products and services. Personally, I'll talk about my background. I had two AI-based startups which I had an exit, and TDM has been existing since 2015, and it has done multiple things. One of the things we do is B2B, B2C, and P2B building platforms. We are top rated in multiple rating organization. We take pride with, we help US Navy, General Electric, couple of the big companies. This is my background. My name is Arshad Khan. I am a computer science and electrical engineer. I have been in this space for more than 20 years. Before I become entrepreneur, I was with Bank of America and Yahoo doing the same thing at an enterprise level. DevMasters, as I said, was started in 2015, funded by me. And my specialization is AI from the college days, but it was statistical modeling. Later on, I went to Cecil Labs at MIT, Computer Science and AI Lab to upgrade myself into deep learning and other stuff to get latest. And in 2015 and 16, again, when I become entrepreneur, and then went to MIT Business Salon for my business education.